Hi, welcome to TechRanch, a place where we learn and earn technical skills in the most efficient way. Let's make coding fun. Java Coding Exercise Series 1, Decimal Binary Number Converter. In this session, we'll see how to program binary decimal number converter in Java using control statements. So what do we learn here? We'll see how we convert decimal to binary and binary to decimal type of number system, logic, implementation, demonstration, and practice project for hands-on experience. Now let's see decimal to binary number conversion. In Algebra, number system provided so many types of number system, where one of them is called decimal number, which is any number in our base 10 number system, which has a radix equals to 10. Similarly, we have another type of number system is called binary number system. Each is a number expressed in the base 2 numeral system, or we call binary numeral system, which uses only two symbols, typically 0 and 1, and whose radix is equals to 2. Now let's take a look at this example. Number 25 is an example and is a type of decimal number which is divisible by 10. Now when we convert it into the binary, so binary radix is equals to 2. So converting from decimal to binary, what we are going to do, we are going to divide the decimal by binary, now radix, which is 2. Now when we divide 25 by 2, we got 12, and it will give you one remainder. Now 12 is your quotient and 1 is your remainder. We are going to put this remainders in a buffer, and we keep on dividing the quotient by radix of binary number, that is 2, until it will be 0. So when we divide 2 by 12, which is giving you 6, and remainder will be 0, and so on. Again, we divide 6 by 2, will give you quotient 3, and remainder will be 0, and so on. Now when we read this particular remainder, we saved it in a buffer from bottom to up. The binary number is ready for you for 25. So this is the process or a logic of decimal to binary number conversion. Now let's take a look at the implementation, the logic. These type of logic or algorithms can be implemented number of ways. Now here, this is my Eclipse IDE, and I'm just going to have a class. So here we are going to implement the decimal to binary demo and just have a main method. First thing first, we need to import the package, and since we are going to get the value from the user, so let's have util package imported already. Now inside the class, first thing we have to have our static method, which is your decimal number and your integer variable decimal number as an argument. Now first, and then we have to have our array variable, so binary variable, which we are going to store the remainder in the array variable. So let's have our size, not 1000, we don't need 1000 size, this will be more than enough. And next we have the loop variable, and let's have our while loop, where the condition will be your n variable, the digital value, decimal value you have entered, binary array variable, which is reading our index I, and equals to n modulus 2. Now once the remainder is saved in binary array variable, next we have to have our n number divided by 2 again, and I has to increment it unless the condition is true. Now once this is done, the next is we have our in reading loop. So for that we need I decremented by 1, because we have to read our remainder array variable from bottom to up. So we have to put the condition like this, and decrease the loop variable. And since we know the binary variable, we have to print it in series, so we are not going to have it in a new line. Now let's call it in the main method. So as per the util package, first thing we need to have our scanner variable, scanner object. And once it is done, then next we have we ask user to enter the variable, enter decimal number and int, and for processing it and printing it, or we can just call the method. Now before that, we are missing something here. We have to get the variable and get it from the scanner and initialize it from the scanner, and that variable is basically your decimal. Now let's take a look at the execution for decimal to binary. Suppose I gave 25. So here is your binary number converted from your decimal number. So this is what the implementation of decimal to binary number conversion. Now let's take a look at the binary to decimal number conversion. So we have seen binary is basically symbolized by two numbers, 0 or 1, and it has a base or radix is equals to 2, which is nothing but the powers of 2. So you can see here the theory goes like this. When we have a binary number 0 0 1 0 0, as you can see, this is like on and off and on and off, true, false, so many ways you can define it. Now in general, in the mathematics, the 0 1, which is in a stream, is going to be converted into the decimal. It has some significance, it has some meanings. So what we can do here, we started from right to left, and the weight goes from here. 2 is equals to 0, which is nothing but the 1, and 2 equals to the power 1 is equals to 2. So this is symbolized of your stream of binary number, and that has the significance when we keep adding, when we have any one value and give the powers of 2 and add and cumulative that number, and that will give you your decimal number. So this is the traditional way to convert your binary number to decimal. Now let's implement it in Java and see how it works. So first thing first, we need to have a class binary to decimal. And import Java util and your main method public static void main string args arguments, and here you go. Now after that, we have to have a static method for conversion, which is returning, so decimal, or this will be your binary conversion. So we can have decimal number method and having an argument n. So definitely we have going to have return, and we'll see the variable what we are going to put it. Now first thing, let's initialize some variables and assigning it to some variable which your user is going to enter. Integer decimal number, decimal value which is equals to 0 in the beginning. So declaration and initialization, and we need one temp variable where we are going to store it the cumulative number what we are going to adding in the decimal. So this variable is going to start from num. Now let's have a loop, while loop, and the temp variable which is assigned to user enter variable which is greater than 0, the condition will go on, and int last digit, basically the last digit of the binary number, which is equals to your temp modulus by 10. 10 is a decimal radix. We have, or base, or you can say signifies a number. So we need to calculate with base of 10 and divided by 10. The same way we did it for binary, we are going to do it for decimal. And the decimal value is going to add with last digit, right? So what we have, the decimal value and your last digit and base of your base multiplied by base. But we don't have base variables, so we need to define it too. And the base is equals to base multiplied by 2, your power method, and returning your decimal value. So once this is done, then all we need to just get it the value from the user, the binary value, and the same way we did it for and enter the binary number and in dot next integer value, and once this is set, next step calling that method. But we have to print that variable, so maybe we can call it in the system method. So let's see, I gave some, so this is what your binary to decimal number converter. So we have seen number systems conversions from binary to decimal and decimal to binary with live demonstration. Now for practice project, what you can do, you can convert the other type of number systems like hexadecimal, octadecimal, and many more. Implemented in Java, or you can practice your control statements and array variables and array implementation. Uses these type of number system being used to program various machines in a different types of number system. So if you have seen hexadecimal type of number system being used for address or any memory locations, reading their memory locations. So these type of algorithms are being very used in very important places like reading a memory and many other networking systems and embedded systems. So these type of algorithms are very important and very useful to use it in your application. For more assistance and source code, please contact techcrunch2019@gmail.com. In the next session, we are going to see swapping and prime number and many more such coding exercises for practice. Stay tuned and please subscribe for our channel, and don't forget to press the bell icon for get the updated notification. Thank you so much for watching this video. Let's make coding fun. Thank you.